Let's look at the production of hydrogen gas. This is the steam reforming process, SMR. The products are what's called synthesis gas, and this is typically done at high temperature with a nickel-based catalyst. If you want to see more on this process, take a look at the credits at the end. It's endothermic, positive 206.0 kilojoules for this reaction, the way it's written. Well, it's common to take that carbon monoxide that's produced and then continue to subject it to steam to produce carbon dioxide and more hydrogen gas. It's exothermic, negative 41.0 kilojoules, and this second reaction is called the water-gas shift reaction. It can be done both at low and high temperatures. It's kind of challenging because while it's thermodynamically favorable at the low temperatures, it's kinetically favorable at the high temperatures, in other words, speed of reaction. So there's a balance going on between those. Now, I'd like to write an overall reaction that describes the sum of these two. But before we do that, let's look at it from a mathematics point of view. Here I have two equations. I have no idea what they describe. I made them up. And I want to add those equations up. You've done something like this before. Goodness knows how many times. So we're going to add up everything to the left of the equal sign, and then we're going to add up everything to the right of the equal sign. Okay, so 2x. We get a total of 5y, and then we have a z. Now for the right side of the equal sign, there's a z, and then 28. Now you see that you have a z on both sides of the equal sign. So what are we allowed to do? Subtract z from both sides. So you end up with 2x plus 5y equals 28. Now you probably didn't even do it this way. You may have learned to do it this way initially, but you tend to skip a step once you get used to it. So let's do the same thing down below. You're told that you're adding those two equations up, and you quickly see, oh, I have z on both sides of the equal sign. So you remove the z, you add everything up, and there's your 2x plus 5y equals 28. Now the reason why you subtract z from both sides is not because z is 0. It's because it's the same on both sides. If z equals 42, you have 42 on each side, you get to subtract 42 from each side. So let's use that idea with the thermochemical equations that we're adding. So the sum of these two is just adding them up. So let's add up the reactants and then add up the products. So we have a CH4, we have two H2Os, we see that there's a carbon monoxide on both sides, so we'll go ahead and remove it, just as if it were Z. We have a carbon dioxide, and we have 4 hydrogen gases. Since we added the chemical equations up, we can then add the standard enthalpies of reaction up. Total is positive 165.0 kilojoules, which means this reaction, the overall reaction, is endothermic.